Students, let's look at this question here, which was taken from the year 2020, NYJC paper 1, question 6, prelim paper. Okay, so question 1, part A. So A, part 1. So this case here, we are given that tangent 2 theta is 2 tangent theta over 1 minus 2 tangent 2 using show. Okay, I think this is pretty okay. So tangent 2 theta, just using tangent A plus B, right? So this is theta plus theta. So not really an issue here. So this is tangent A theta plus tangent theta. Okay, 1 minus tangent theta times tangent theta. So just use this is use the formula from MF 26. That's about it. Okay, so once this is done, let's look at the subsequent one. So let's look at the subsequent part by using the substitution x equals to at theta, or otherwise find the exact value of 0 to 1 tangent inverse. Okay, so you could see here actually the tangent inverse here is here, right? This term here. So that's what we need to do. But first of all, if you're going to use substitution, just differentiate this first. So for the first part, what I would suggest is just take x equals to tangent theta, and which is dx d theta will just be secant square theta, right? Then in this case here, because this is dx, so we need to send dx out. So dx will just be secant square theta. But just take note, some schools don't allow you to write this out. But even if you write this out, in most textbooks, it's fine. You will see this in university textbook. Okay, so I know some schools don't allow. Okay, let's look at that. So we're gonna start at 0. So I'm going to put this as a theta. So 0 to 1. Okay, then this is tangent inverse. Then we have got 2x minus 1x squared dx, right? Now this is very important. When you try and use substitution, the first thing you should try and do is you just key in calculator. So just change this to d theta, change the rest out. Okay, so this case here, when you change it, make sure you change the boundary as well. Leave the boundary aside. Then this will be tangent u, because now tangent x is is 1 minus square theta. Dx will just be secant square theta d theta. Okay, so that's pretty okay. Now once that is done, what we need to do now is just look at this case here, the boundary. Just take note, this is very important. So this is when x equals to 1. So when x equals to 1, tangent theta equals to 1. Use this formula here. Theta equals to pi over 4. That's 45 degrees. Okay. So this is pi over 4. Then when x equals to 0, then theta equals to 0. Just make sure you get over there. So this is 0 and pi over 4. Now once done, we're going to use the one. So the previous method is tangent inverse to tangent theta, 1 minus tangent square theta equals to 2 theta. So what we're going to do is just replace this as this whole thing here as my 2 theta from 1, right? From A, from 1. This is 2 theta. Okay, so what we're going to get is actually, this will just be 0 pi over 2, pi over 4, 2 theta, secant square theta, d theta. Now once you see this, don't get intimidated by this. You can algebra here, and this is a trigo. So obviously this has by parts, right? So you can let your u, this is u, this is dv d theta, because this can be integrated. So d theta, this is u, then d v d theta will be secant square theta, then v will be tangent theta, u du d theta will just be 2. Okay, so this case here, once done, we're gonna uv, so this is 2 theta, tangent theta, bracket it, pi over 4, 0, minus of 2 tangent theta, d theta, which is 0 and pi over 4. Okay, it's pretty okay. Here, integration of tangent theta, remember this is MF 26. 26. Okay, so out MF26, you need to know what are the integral forms we have in MF26. In the MF, you were told that tangent theta integral will be ln secant x. Okay, so just use that. We're going to use that here. Will just be this will be, okay, let me just write it down. This will be 2 pi over 4 tangent pi over 4 minus 0, okay, minus 2 ln secant theta pi over 4. Okay, so this case here, what we get is actually half pi. Tangent pi over 4 is 1, so I'm going to use this as 1. Minus of 2, this is actually 1 over cosine pi over 4 minus ln 1 over cosine 0. Okay, so I'm just going to keep this in. Cap is half pi. Then what we get is half pi, then this will just be minus 2 cosine 1 over root 2, so this is root 2 minus ln 1, which is 0. That will be half pi minus 2 ln 2.5. This will just be half pi. This half bringing it down will be ln 2. Okay, so that's how we do this question proficiently. If you have any questions or comments at all, please let us know. Keep practicing and I'll see you in the next question. Let's look at part B. Part B, we're told to find this integration here, 2 plus mod x over 2 plus x. Okay, let's see how we can do this. Now, the first thing for modulus function, I will suggest that we at least draw the curve out, because mod x, okay, let me just draw it out for you, because mod x can be positive x or negative x, okay, depending on which, when x bigger than 0 or x less than 0, right? So we know that, but I'm going to just point it out and show you. For modulus function, when you do the integral, is just draw the graph, okay? Then you won't do anything wrong there. So this will be function, just put 2 plus absolute, so absolute value will be math number absolute, you put x here, and that will be 2 plus x. Okay, so 2 plus x. Now once this is done, just graph it. You know that, wow, this graph is interesting. Zoom 6. Okay, this is a very interesting graph. So you're looking at minus 1 to 1 here. Do you see that, the 1 and the 1 here? Now what's going on in this graph here? So let me just go to Windows settings. I'm going to put minus 2 to 1, because ultimately what we want is just 1 to, let's do this. This is what we want, right? So ultimately, let me just put this x min as x2. Okay, this is what we want. So ultimately, we just want these two graph here. All right, so let's see how we do that. So how do we make sense of this? It's actually pretty okay. First thing is, you must know that there are two functions at play. Function number 1 is where you take the positive one, so it will be 2 plus x over 2 plus x. And the other one is when you takes negative 2 plus minus x over 2 plus x. This is 2 minus x and 2 plus x. Okay, there are two functions at play here. So this is actually 1. So it doesn't take long for you to know that actually this is y equals to 1. Okay, this function here, this one here is y equals to 1. Whereas for this case here, this other line here, which is actually taking the positive. Remember, modulus, we have two functions, okay, is this one over here. Okay, so when you are taking from minus 1 to 0, you should take this function. Then when you are taking from 0 here to 2, you should take this function, number 1. Okay, so remember that very carefully. So this part here, once you're done, I'm going to find this by splitting this up. So I know that this will be minus 1 to 0, 2 minus x, 2 plus x dx, plus 0 to 2, 1 dx. Okay, so this case here, how do I integrate this? Remember, you need to know how to integrate this. Okay, you need to do a long division. So please, by the side here, do a long division. So x plus 2 minus x plus 2 minus 1 minus x minus 2. This is 4. So this case here, what we get is actually just minus 1, 0. And this will be negative 1 plus 4 over x plus 2 dx. Okay. So once this is done, this will just be x 2 to 0. Not an issue, no sweat there. This will be negative x plus 4 ln x plus 2. There will be 2 there. This will be 0 and negative 1. So this will be 0 plus 4 ln 2 minus of negative 1 plus 4 ln 1, which is 0, plus 2. And then what we'll get is actually 4 ln 2 plus 1. Okay, so this is the exact value that you get. Yeah, please remember modulus graph, just mod it, because if you don't mod it, you won't be able to see it. Let me see. Did I copy the question wrongly? Oh, sorry. You need to be 1. Yes, this is 1 here. This is 1 and this is 1. Yes, so this is 1. This is 1. 0. So this is how I do this question here proficiently. If you have any questions and comments at all, please let us know. Keep practicing and I'll see you in the next question.